Hi everyone, it's Rohan this side from Lemniscates Academy. And in this video, I'm going to help you understand step by step all the solutions for this MCQ paper that recently occurred in the October-November 2024 sessions of Cambridge Assessment International Education. So yes, this is a CAI paper. Subject code is 9702 for physics in CAI, and 12 is the paper code, 1 for the MCQ, and 2 is the variant that we are going to solve. Now, for any kind of doubts with respect to whatever I'm explaining in this video, if you're not understanding any kind of solutions or any kind of a step in a solution, please make sure to comment it down and I'll reach out to you as soon as possible. And the second thing that I wanted to mention is that if you want to contact me for the online classes for AS and A-level physics and mathematics, please use this WhatsApp number. And yes, let's get started. So the first question is about a physical quantity consists of a magnitude and a unit. Now we have to find which row does not show correct combination of a quantity and its respective units in which we can measure it. So over here we know that we can measure mass in kilograms. Now kilograms is the SI unit. Over here they have not really specifically mentioned about SI unit, but just a unit in which we can measure the respective quantity. So yes, because we know that we can measure mass in kilograms, so obviously gram is a correct unit for mass. So the first row is a correct combination. And in the question, we need to focus on which row does not show the correct combination. So yes, A cannot be our answer because it shows the correct combination of the quantity and the unit. Similarly, my option B also is having the correct combination because I can know that length can be measured in meters. And similarly, my row D also, temperature can be measured in kelvins. But then if I talk about rho C, my charge cannot be measured in amperes because ampere is the unit for current. And the charge unit is going to be coulombs, not amperes. And therefore, C is the correct answer because this row does not show the correct combination of a quantity and its respective unit. Now let's talk about our second question. It states that a small car travels in a town. Note that it's talking about a small car. Now, what is a reasonable estimate of the kinetic energy of that car? So over here, we just need to estimate, first of all, what will be the mass of a small car, and secondly, what will be the velocity or an average velocity that we can estimate for that small car. So let's say we say that kinetic energy, we know the formula is given as half mv square. So obviously the first value will not come exactly 5 because we are taking random values or estimated values. Uh, and based on that, we just need to focus on the powers and not the first value. And therefore, if I just have my half, and let's assume that the small car is having a mass of somewhere 1000 to 1500 kgs. Let's take a value between that. So 1250 kgs, let's assume. And then if I talk about the velocity in which a car travels, a small car travels, let's keep it to be, let's say, 45 kilometers per hour. Now note that I'm saying kilometers per hour. Now this is not an SI unit, but then if you notice the answers, like the options, all of them are measured in joules, which is the derived SI unit quantity. And therefore I'll need to convert this into meter per second. Now how can I do this conversion? First of all, let me just write 45. Now this is in kilometer per hour. So I'll convert my kilometer to meter by multiplying it by 1000. And then to convert my hour into seconds, I know that there are 3600 seconds in an hour because in 1 hour there is 60 minutes and in 1 minute there are 60 seconds. So yeah, there will be 3600 seconds in an hour. And that is how I'm going to convert my 45 kilometer per hour as my meter per second. And then because it is a square of the velocity, I'm going to square it up. Now, if I just plug in all these values to my calc and get my answer, half into 1250 and then 45 into 1000 divided by 3600 square, my answer is coming out to be 9.7 9.7 into 10 power of 4. So as I mentioned, this value will be approximately close to what we are having over here. So we don't need to focus on that because of the reasonable estimate. But if I then see, if I compare my powers, 4 is the closest with respect to my option A. If I compare with B, C and D, the powers are very far away from 10 power of 4. And therefore, A must be your answer. Let's say even if you get 10 to the power of 5. Now 5 is closest to 10 power of 4. Then in that case also A will be your option. Let's say for example you are choosing some different values, slightly different values. Let's say instead of 45 you are choosing 50 and you might get 10 to the power of 5 over here. It's completely fine. Even though 10 power of 5 is not in the option, but it's closest to option A. So our reasonable estimate for the kinetic energy for the small car will be 10 to the power of 4. It's closest to our answer. So that is how you do question 2. Now in our third question it is mentioned a solid bar has a square cross section. A solid bar has a square cross section. Now, the length of this bar is measured as 50 with plus minus 0.2 being the absolute uncertainty. Note that the unit for this quantity is centimeters and the width is measured as 2 centimeter with plus minus 0.01 centimeters. Now, these values are used to calculate the volume of the bar. What is the percentage uncertainty in the calculated volume? So over here, the volume can be calculated as the area of the square times the length, and therefore it's going to be volume is equal to the width square into the length. That is how you will be calculating the volume of the bar, right? Let's say this is the kind of a bar that I'm trying to draw over here. Even though it does not look good, but yeah, over here we are talking about the width and the length. And now if I talk about the percentage uncertainty in the volume, this will be equal to 2 times delta width divided by the value of the width into 100 plus why 2 times, because it was squared, that is why 2 is written over here. And for the length, because we are dealing with the multiplication, we know that the value will be added over here. So plus the uncertainty in the length will be 0 point, or I should say delta length divided by length into 100. And now if I just plug in the values, so 2 into 0.01 divided by 2 into 100 plus 0.2 by 50 into 100, and then if I calculate this percentage, the output that I'm going to get is so 0.01 into 100 plus 0.2 by 50 into 100. So it comes out to be 1.4 percentage, and therefore D comes out to be our answer. Okay, so that is how we have solved question 3. We got the idea of what is the kind of object that we are dealing with. We know about its length. We know that the cross section is a square, and therefore the volume can be calculated as the width square times the length. And yeah, that is how we are going to get the answer for our question 3. Now, in our fourth question, it is showing us the graph for the acceleration of an object moving in a straight line as it varies with the time. So as time is passing by, we can clearly see how the acceleration is going to behave. Now, the object starts from rest, which means initially the velocity will be equal to 0. V is equal to 0 at time is equal to 0. Now, which graph shows the variation with the time of velocity of the object over the same interval. That is what we have to figure out. So if you see that in all the four options, the velocity is starting from zero. So there is no good understanding based on, like, if let's say one of the options was starting from here or wherever it is possible, but not zero, then we can straight away cross out that. But that kind of thing is not given in the MCQ, but it's completely fine. See, we know that uh, my acceleration is nothing but dv dt. That is, if you are coming from mathematics background, you must be understanding what I'm talking about. If you are not from the mathematical background, this is nothing but change in velocity with respect to change in time. So gradient of Vt graph is equal to acceleration. We know this. So from all the available options, if I just understand how the gradients are changing, and then if I compare with respect to our acceleration, then we'll be able to answer this. So wherever we see this kind of flat surfaces over here and over here, clearly on these points, if I draw the tangent, tangent will be with respect to my x-axis. And because of that, the gradient of these lines are equal to 0. So because on the starting and the ending position, the value of gradient is 0, it means that the acceleration value is also 0. And if I look into the graph, acceleration is indeed 0 at the start and at the end. Then if I just keep on drawing the tangent over here, it's increasing, increasing. It goes to the maximum value over here somewhere, and then it starts decreasing. The tangent's gradient starts decreasing and eventually approaches 0. So what is happening to the gradients? It was 0, then it rose, went to a maximum value, then it came down, 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 and then came up all the way to 0. And this is exactly what we are able to see in this particular acceleration time graph. So straight away our answer seems to be A. Okay. If we compare exactly the same thing with the B, if I take the gradient at starting point and the ending point, we know that acceleration will be 0 because, yeah, with respect to this gradients for the tangents, both of them are 0. But then even over here, if I draw the tangent, so at that point, my acceleration will be 0. But we can see that that's not the case. Acceleration is maximum. So therefore, this cannot be the option. For C, there is acceleration equal to 0 over here and over here because the gradient for the Vt graph in both the cases are 0, which is again not the case. And for D, we can see that clearly initially acceleration was 0 or the gradient of the Vt graph was 0, but then it keeps on increasing, increasing, increasing. So even this is not possibility. So the only answer that we are having for our question 4 is option A. I hope it has given you some idea of how to solve this kind of a graphical question. Now, a stone falls vertically from rest. So initially, the value that is given to us for the velocity is 0. What is the speed of the stone? So final velocity is what has been asked. Once it has fallen through a distance of s is given to us 0.4 meters. And because air resistance is negligible and it's falling vertically, so we can assume that my A is equals to gravity, right? Which is 9.81 meter per second square. So I know that my V square is equal to U square plus 2AS. So my V will be equal to square root of U square is 0 square, then 2 into 9.81 into 0.4. And then if I calculate the value of V over here, square root of 2 into 9.81 into 0.4, it comes out to be 2.8. So B is the correct option for question 5. Now for our sixth question, it is mentioned that a ball is thrown horizontally off a tall building. The ground is horizontal and the air resistance is negligible. So the kind of a diagram that we are having is something like this. We are having a building, we have a flat ground, and then if a ball is thrown, because of the Earth's gravity, it's going to come down, 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 and hit the Earth. So the acceleration of the ball is always at the right angle. No, that's not the case. Because if I talk about the acceleration over here, acceleration in the x direction is always going to be zero because there is no force which is going to push or pull the ball. And therefore, in the x direction, there is no force and therefore no acceleration. But then if I talk about y, the value of the acceleration in the y direction, obviously Earth is trying to exert a attractive force on the ball, and therefore the constant acceleration that you're going to feel, approximately it's going to be 9.81 meter per second square. That is nothing but the gravity of the Earth, the g. So the only gravity that we are having is acting vertically downwards, and we can see that it's not always 90 degrees with respect to the path of the ball. So simply we can cross out A. Now if I talk about B, the ball follows a circular path until it hits the ground. That is again not the case. In that case, it's going to be something like this. So yeah, that's not the case. We are not having this kind of a thing, and therefore B is also not the correct answer. The ball has a constant acceleration for sure. This makes sense because we know that there is no component of acceleration in x direction, and the only acceleration we are having is in the y direction, which is not changing. And therefore, the ball has a constant acceleration. It is because of the Earth, and thus C is going to be our correct option. Now, for the seventh question, it is given that a moving object strikes a stationary object, which is an inelastic collision that we're going to have if they're going to move together, and that's exactly what's happening over here. A moving object strikes a stationary object. The collision is inelastic, is already mentioned, okay? The objects moves off together. Okay, so once we collide, both the masses are going to be fused inside it together and then move with a constant velocity, like common velocity. Assume that two objects from an isolated system, that is the condition for the collision, for the momentum formula that we use in the AS level physics. Now, which rho should be the possible value of the total momentum and total kinetic energy for the system before and after the collision? So we know that Ke is conserved only for elastic collision, and because our collision is inelastic, K is not conserved over here. But momentum is always conserved. Okay, momentum is conserved. So conserved basically means that initial and final values are always equal. Not conserved means they are not equal. So we need to find out of ABCD where P is conserved, where the final and the initial value of the P is conserved or equal. So in BCD, that is what we can see. So A straight away gets cancelled out because the total momentum before and after does not match, which states that momentum is not conserved, which is not true, and therefore A is going to be crossed out. Now we need to find out K is not conserved, which means the value of K cannot be equal. Over here we can see that the total kinetic energy before and after the collision are equal in this option. So D also gets ruled out. We are left with B and C. So initially, there was some kind of an object that was rushing towards another object which was stationary, which was over here coming with some, let's say, velocity v. And let's say this is m1, this is m2. Now, after the collision, my m1 and m2 are going to be fused together and now move with a new velocity v1. Now, after the collision, because now my one object has collided with the another object, the speed will be decreased. And because the speed will be decreased, we know that the kinetic energy is half mv square, that is directly proportional to the square of the velocity. And if the value of the velocity is decreased, my kinetic energy should be less after the collision as compared to before the collision. And therefore, option C makes the sense over here because after the collision, the K is less as compared to your initial kinetic energy. So that's how C will be the answer for our seventh question. Now for our eighth question, the graph show how a quantity y varies with a quantity x for an object falling vertically at its terminal velocity. So what happens in the terminal velocity? You are not experiencing any acceleration because you are traveling at a constant velocity. So terminal velocity is nothing but where your acceleration will always be zero because v is equal to constant. These are the kind of ideas we know. Now over here, we need to identify what could be our x and y. So I know that my acceleration will always be zero. So with time, my acceleration cannot decrease. It will always be zero if I'm talking about the terminal velocity. So A cannot be our option. Now, if I talk about B, if we are coming down and down and down and down with respect to the surface, we can see that the height is continuously decreasing with respect to time. So B could be correct, but let's check option C and D. Now, it says that as the distance is moved, my kinetic energy is going to decrease. How does that make sense? Because velocity is constant, so my k will also be constant. Half mv square is what is the formula for kinetic energy. It's independent of the height. And because v is constant, my k should be constant. And same applies for option D. Velocity is constant, it's not decreasing. And therefore D is also ruled out. So B, as we thought of, is the correct answer for our question 8. Now for question 9, it is given that a ball of mass 2 kgs, so mass is given to us as 2 kgs, it's traveling horizontally with a speed of 4 meter per second. The ball collides with a wall and rebounds in the opposite direction with a speed of 2.8. So it's a classic example of momentum. It's coming with 4 meter per second. And then because it's changing the direction, we are going to say that it's minus 2.8 meter per second. And then the time of the collision is 150 milliseconds, which is same as writing 150 into 10 power of minus 3 seconds. What is the average force exerted on the wall? So we know that force is equal to rate of change of momentum. So m final velocity minus initial velocity divided by time taken. So my m is given to us as 2, final is minus 2.8, initial is 4 divided by 150 into 10 power of minus 3. And if you calculate this in your calci, let's see what value do we get. So 2 into minus 2.8 minus 4 divided by 150 into 10 power of minus 3. It comes out to be 90.666 with a negative sign. So D must be our answer. Obviously, we can ignore the negative sign because it's just showing you the direction. But the value of the magnitude of the force is coming out to be 91 newtons because 90.66 is what we are getting in the calci after putting these things in the calci. So D must be the correct option for question 9. Now let's talk about question 10. In question 10, two train carriages, each of mass 5,000 kgs, roll towards one another on a horizontal, frictionless track. One is traveling at a speed of 2 and the other one is traveling at a speed of 1. They collide together and join together, so which is again inelastic. Now because it is inelastic, K is not conserved and therefore there is some kind of a kinetic energy lost during the collision. So what is that kinetic energy lost? So to find out the initial kinetic energy, it's very simple. So kinetic energy initial is equal to half 5,000 into V square, which is 2 square, plus half 5,000 into minus 1 square And if you solve this in the calci, half into 5000 into 2 square plus half into 5000 into minus 1 square, it comes out to be 12500. This is your initial kinetic energy, not the lost. So option D obviously is not the correct one. Now let's talk about kinetic energy final. So for the final, both of them are going to be a single mass and the weight is going to be 10,000 kgs. And now it's going to travel with a velocity of v. We don't know what is the value of this v. So we can use the concept of conservation of momentum where we know that the initial momentum is equal to the final momentum, and therefore initial momentum will be equal to 5000 into 2 plus 5000 into minus 1. Why minus 1? Because it's traveling opposite to the first one, so change in sign. And my final momentum will be 10,000 into v. And once we equate them and try to solve for v, it is going to become 5000 into 2 minus 5000 into 1 is equal to 10,000 v. And therefore v comes out to be 0.5 meter per second. And then if I'm using this concept and putting down this value for the kinetic energy final, it's going to be half into 10,000 mass into 0.5 square. So half into 10,000 into 0.5 square comes out to be 1250. So this is final. So now what is lost? So 12500 final minus initial is what we need to do. So 1250 minus 12500. Therefore, lost KE is KE final minus KE initial comes out to be minus 11250. So 11250 is lost. Lost is negative. So 11250 must be our answer. So that is how you solve question 10. You first get the kinetic energy before the collision, then you get the kinetic energy after the collision, then do final minus initial and that will be a lost value. Now the question 11 states, which single condition must apply for an object to be in equilibrium? Well, for any object to be in an equilibrium, there are two conditions that we need to see. First of all, the net force acting on the object must be equal to 0 and the net moment must be equal to 0. So based on all the options, if you read the option D, the resultant force acting on the object is 0, and that is what is one of the condition, and therefore D makes sense to be the answer for question 11. Now for question 12, it states that a kite is in equilibrium at the end of the string as shown. Now there is a weight component over here. There is a string because of which the tension is going to act in this direction, and then there is a force from the wind, and because it's an equilibrium there will be a closed triangle, which means there will be a complete loop that will be followed. Okay, so the whole cycle will be completed. So first of all, let's see in which the cycle is completed. In option A, the cycle is completed. We can see that the whole cycle is completed. In option B, we can see that cycle is not completed over here. In option C, again cycle is not completed in this case. And in option D, the cycle is not completed. So the only possibility that we are having right now is A, where the weight is acting downwards, the tension is coming over here. So A makes the only sense as compared to other options. Now going to question 13. Four forces acting about a point P. The force act in the same plane and produces no resultant moment about point P. So net moment is 0. And in that case, we need to find the length of xy. So this is x, this is y. We need to figure out this whole length. Let's just assume that this middle part is equal to L, and therefore this part will be the whole xy, and if we take away the L, so we'll be getting this part. So that will be xy minus L. Now because they are in the same plane, let's see first of all which of these forces are going to contribute to the clockwise moment, and then which of these forces will be contributing to the anti-clockwise moment. And then we can say that sum of a clockwise moment will be equal to sum of anti-clockwise moment. So if I talk about the 6 Newton force, it is going to contribute towards the clockwise moment, and so does this 6 Newton contribute as well. If I talk about X force, it is going to contribute in the anti-clockwise motion, and even this is going to be contributing to the anti-clockwise. So this 6 and 6 is going to contribute to the clockwise, and the 5 5 is going to contribute to anti-clockwise. So we can say that sum of moment in clockwise is equal to sum of moment in anti-clockwise. So in clockwise we have 6 into 7, which is 42, plus 6 into 3 is 18. 6 threes are 18, is equal to, now if I just see, moment is always the perpendicular distance from the force. So if I need to find this, I am given this angle as 60, so even this angle must be 60, and therefore if you use the idea, if I want to resolve with respect to L, on the x-axis it's going to be L cos 60 because angle is coming in between, and for the y-axis it's going to be L sin 60. So it's going to become with respect to this 5, it's going to be 5 into L. I want the perpendicular over here, so it is L sin 60. So L sin 60 into 5 is what I am getting over here. So 5 into L sin 60 plus over here, if I try to get this vertical length, so xy minus L, again I'm going away from the angle, so it is going to become the force, which is 5 times xy minus L times sin 60. And then if I just solve this, 42 plus 18 is 60, is equals to 5L sin 60 plus 5 sin 60 xy minus 5L sin 60. So 5L sin 60, 5L sin 60 gets out. And if I make xy the subject, answer will be 60 divided by 5 sin 60. Make sure your calc is in degrees mode. And now if you try to solve this part, 60 divided by 5 sin 60 comes out to be 13.8. So 13.8 is nothing but close to 14. So C must be our answer. Now, if I talk about question 14, a rectangular block of lead of density, so the value of the rho is given to us as this, has sides of length 12 centimeter, 15 centimeter, and 10 centimeter. Now, what is the maximum pressure that the block can exert when resting on a table? So, we know that pressure can be written as force divided by area, where my force is equals to rho gv, in this case rho gv, because rho into v is mass and we know that F is equals to mg. So m can be replaced as rho v and g is written as it is. So rho gv is the force divided by the area. Now area could be multiplication of 12 15, 12 10, or 15 10. But then we need to find out the maximum pressure. So maximum pressure can only be found when the area is minimum, because smaller the denominator, larger is the value of the fraction. So A will be minimum when I'm having the product of the minimum lengths given to you out of 3. So 12 and 10 are the minimum values out of 3 values. So if I multiply my 12 and 10, I'll be having the minimum area possible. And that is how I'll be getting maximum pressure. So maximum pressure is when we are having area minimum. So area minimum in this case will be equal to 10 centimeter into 12 centimeter. And I'm converting my centimeters to meters by multiplying with 10 power of minus 2. So it is 10 into 12 into 10 power of minus 4. So my area that is going to be giving us the maximum pressure is 0.012 meter square. And therefore the final pressure will be equal to rho GV. Rho is given to us 1.13, 10 power of 4, G is 9.81. Volume is nothing but the multiplication of all these three things. So 12 into 15 into 10, and then 10 power of minus 2 for this, 10 power of minus 2 for this, 10 power of minus 2 for this, so 10 power of minus 6 to convert all of them into meters, divided by 0.012 is going to give me P max. And then if I use my calci, 1.13 10 power of 4 into 9.81 into 12 into 15 into 10 into 10 power of minus 6, and then divide it with 0.012, it gives me 16.627, which means 16.6 kilopascals. So D comes out to be our answer for question number 14. Now, for question 15, it is asking us what is the definition of a power. So power is work done per unit time, which is option D. So D makes sense for our question 15. Now if we talk about question number 16, it is given that a model car travels at a constant velocity of 12 meter per second. So V is given to us as 12 in a straight horizontal line. The input power to the engine is given to us as 800 watts, and the efficiency of the engine is 60%. Now what is the total horizontal resistive force on the car? First of all, it is a constant velocity, which means that if this is a flat road and here is my model car, and if it's continuously traveling at a constant velocity, it means that the acceleration is zero. So the driving force must be equal to the resistive force. Only in that case my force cancels out and my net force is equal to 0. And if my net force is equal to 0, I know that F net is equal to ma. So my acceleration must also be 0. And if my acceleration is 0, it means it is traveling at a constant velocity of some value 12 meter per second. That is what is the idea. Now, to calculate the driving force, we need to get an idea of how much amount of power is generated with respect to the engine. So, power input is given to us as 800 watts, and the efficiency is given to us as 60%. So, the output power that we are going to get will be 60% of 800. And if you calculate 60% of 800, 60% of 800 is coming out to be 480. That is 480 watts. So this power is generating the driving force. And we know that power is equals to Fv. So F will be equal to power by velocity, that is 480 by 12. So 480 by 12 comes out to be 40. So FD comes out to be 40. So over here FD must be equal to FR for your acceleration is equal to 0 condition. And therefore resistive force is going to be equal to 40 newtons. So that is how we calculate the value of the resistive force based on the given circumstances. Now, for the 17th question we are having, which statement represents the principle of the conservation of the energy? It is basically that total energy in closed or isolated system is always constant. And this is clearly given in option C, so C becomes our answer. Moving on towards question number 18. A barrel of mass 50 kg is loaded onto the back of a lorry that is 1.6 kilometers or 1.6 meters high. So vertically, the height is 1.6 meters and it's going to be pushed up on a frictionless plank of 3.4 meters long. Now, what is the minimum work done? So now you can over here you can use the work energy theorem, that is delta work done is equals to delta Ke plus delta Pe. Now, to get the minimum work done, I don't want to add some value to my kinetic energy, or I should say that to get the minimum value of the work done, I know that there is a change in height, so for sure there will be some value of Pe. Now I don't want to add some extra quantity of the Ke, so we can say that for the minimum work done, the velocity must be constant. So in that case, this will be eliminated. And if this is eliminated, we are just left with delta work done is equals to delta P. So delta work done can be written as my work done because of the driving force minus work done because of the resistive force is equals to mg final height minus initial height. Now there is no resistive force and therefore this becomes 0. So you are just left with WDF, which is equal to mg, where m is 50, g is 9.81, and the final height is going to be 1.6. Initial height was 0. And therefore, if you calculate your final work done, that is going to become 50 into 9.81 into 1.6. And if you calculate this 50 into 9.81 into 1.6, it comes out to be 784.8, which means option C. An alternate way of doing the same question could be with respect to this concept, that if I am able to find the force which is in the direction of the motion. So in that direction, there is only one force, which is going to be the force of gravity with respect to the weight of that object. So over here, we know that this is 1.6, this is 3.4. You can find out the value of theta, and that theta will be equal to basically sine inverse of 1.6 over 3.4. And then this is mg sine theta, okay, because this is your mg and this is your perpendicular component. Over here there will be theta. So if someone who has done m1 must be understanding this method, and in this case if you do mg sine theta into 3.4, you must get exactly the same value, that is 784.8. You can go ahead and try it out. Okay, if you do 50 into 9.81 into sine of theta, sine of this value that you get, so that is mg sine theta. If you do multiply it with 3.4, that is the force into the distance, that is going to give you the work done. So even this is going to give you the option C as your answer. You can go ahead and surely check it. But either ways, depending on your uh, the speciality or your command on this kind of concepts, you can go with either of the methods. Now for the question 19, what is the unit for stress? We know that stress is equals to force by area. Now force is mg and area is, we know that it's a multiplication of 2 meters. So m is kg, g is gravity or acceleration, so meter per second square, and then area is meter square. So we are left with kg m minus 1 s minus 2, which is option A. And now for question number 20, it states that the graph shows the relationship between stress and strain for three wires of the same linear dimension but made from different materials, which means that Young's modulus will be different. Now, which statements are correct out of the three, and based on which we are having the options? The extension of P is approximately twice that of Q for the same stress. So let's say for the same stress, if I get the output over here for some strain, and for the same stress if I get the output for the Q, we can see that the strain of Q is greater than strain of P. And what is strain? Strain is nothing but the extension over original length. Strain is extension over original length. So for the same stress, if I am getting my strain of Q that is higher than the strain of P, so obviously the extension for Q will be higher than the P. But in the first statement, it's saying that P is twice than Q. That is not true. So first one is incorrect. P is not more than Q. It is less than Q if I'm talking about the strain. For the same stress, the strain of Q is more than P, not less, and therefore the first statement is incorrect. Now, the ratio of the Young's modulus, which is nothing but the gradient of the graph, because Young's modulus can be given by stress by strain. So the gradient of the graph for P to that of Q is approximately 2. So the gradient of P is obviously higher as compared to 2, and because it's higher and both of them are linear and we can manually compare, so approximately this is a correct statement. Now for a strain less than 0.1, so this one, R obeys Hooke's law. So this is my R, and till this point it is a straight line, so even this is correct. So 2 and 3 are correct, therefore C is your correct option. So that is how out of the three statements given in your question 20, first one was incorrect and the last two are correct, and therefore C becomes our correct option. Now for question number 21, it is given that there are four solid steel rods equally contributing or supporting an object that is weighing 10 kilonewtons. It is equally. So four solid steel rods equally are contributing in supporting an object that is weighing 10 kilonewtons. Now each rod is of length 2 meters. So that's the length. I just keep on writing this that the value of length of one steel rod is 2 meters, and cross-sectional area of one rod is 250, then it's millimeter square. So if I want to convert this millimeter square into meter square, I'll need to do 10 to the power of minus 3 and then there is a square. So it becomes 10 to the power of minus 6 meter square. And then the weight of the object, I'll just mark this. The weight of the object, the 10 kilonewton, causes all the rods to contract by 0.10 millimeter. So a particular rod is going to have an extension of, basically the value of x will be equal to 0.1 into 10 to the power of minus 3 meters. Now it's mentioned that the rods obey Hooke's law. Now based on this information, what is the Young modulus of the steel? Now we know that 10 kilonewtons is being equally supported by four different solid steel rods. So if I have to calculate force on only one steel rod, I can do it like 10,000 divided by 4, which comes out to be 2,500 newtons. So now I'm having information for one single steel rod. Now based on this, I can find my Young's modulus by using the formula. My Young's modulus is equal to FL by AX. So F by X, that is nothing but obeying the Hooke's law, that becomes K. You can also write it like KL by A, even that is fine, but it's your wish how you want to write it. So now 2500 into 2 meters divided by 250 into 10 power of minus 6, and X is 0.1 into 10 power of minus 3. That is going to give us the Young's modulus. And now if I just take out my calci and try to solve this, let's see what out of the four options we get over here. So 2500 into 2, and then 250 into 0.1 into 10 power of minus 9. It comes out to be 2 into 10 power of 11, which is B. So the answer for question number 21 seems to be B in this case. Just make sure that you are aware about this idea, that because we are having the information about one steel rod, this is the information for one steel rod. So based on this, we can calculate Young's modulus of steel. So that's how you can go about this particular question. Now moving on towards the 22nd question, it says that the graph shows how the length of a spring varies when the force applied to it, when varies with the force applied to it. Two areas P and Q are labeled. There are two different areas P and Q. Which area represents the work done in stretching the spring? Now we know that this is the initial length. It's not starting from zero. There is some kind of a value of the length from which, when the force is applied, it is being extended, and therefore the length is continuously increasing. So it is for this part where the spring is being stretched, and therefore the work done just in order to stretch the spring starts from this point, ends at this point, and therefore P will be the area that is representing the work done in stretching the spring. So answer in this case would be A. Move on to the next question. In 23rd question, a horizontal beam of vertically polarized light of amplitude A, vertically polarized light of amplitude A is incident normally on a polarizing filter. So there is a horizontal beam of vertically polarized light of amplitude A, and it's incident normally on a polarizing filter. The transmission axis of the filter is at angle of 50 degrees to the vertical, and therefore the formula will become the I transmission intensity of the transmission, or the transmitted intensity, is equal to the original intensity, the intensity at which it is entering the polarizer, times the cos square of 50, because that's the angle with respect to the vertical. So according to the question, this is the equation for the transmitted intensity. Now it said that what is the amplitude of the light in the beam after it has passed through the filter. So over here, we know that when the value of intensity was I naught, at that time, the value of amplitude was A, and we know that I is equal to Ka square. That is, intensity is proportional to A square. So if I'm removing my proportionality sign, I'm having the uh, constant of proportionality, K. And I know that I naught by A square will always be equal to that constant. So when the intensity, that is before passing through the polarizer or the filter, it was I naught, and after passing through the polarizer it's going to be IT, and IT is given by this particular value. Now the question is, what will be the amplitude for IT given that for I naught it was a square? So I can say that I naught by a square is equal to IT by, this is something that I want to find, amplitude for the transmitted light square. So what is the value of AT? That is what I have to find. So if I substitute the value of IT as I naught cos square 50, it's going to be something like this. I naught divided by a square is equal to I naught cos square 50 by a t square. If I just cross multiply this, so my final equation is going to become a t square is equal to, my I naught and I naught are going to be cancelled. It's equal to cos square 50 times a square, which means that my AT comes out to be square root of cos square 50, that is nothing but cos 50, that is 0.64 a, because a square, if you take the square root, it's going to be a. So 0.64 a is what you are getting, and therefore C must be the answer for this question 23. Just note that the relationship, you should be able to find out the relationship of the transmitted intensity with respect to the initial intensity. And then based on that, using this concept that my intensity is proportional to the amplitude square, you get that equation. And using that, we just compared and found out the unknown. This is a very classical question that we get based on this concept in the MCQs. So just make sure you are very much prepared with this type of questions. Now in the next question, it is given that a progressive longitudinal sound, it's a longitudinal sound wave, moves through an air. The diagram shows the position of the particles along the path of the wave at one instant. So this is how the particles are going to look like along the wave. So it's going to be like, compression, refraction, rarefaction, compression, and rarefaction. Now point Q is at a distance x away from P, which graph shows the variation of the displacement of the particle, air particles with the distance moved from P to Q. So this is nothing but a complete wave that we are getting. So the displacement is going to be increasing, decreasing, and coming back to the original position. So that kind of thing is only present in option C. So that becomes our answer. Now moving on towards the next question, we are having that an electromagnetic wave in free space has a frequency of 3 into 10 power of 16 hertz. So there is an electromagnetic wave in the free space which has this frequency. Now, which row gives the principal region of this particular wave? So we know that we are having X-ray, gamma ray, ultraviolet, then the visible light, so on and so forth. So out of all of this region, this frequency belongs to which principal region? And an example of the electromagnetic wave with a lower frequency. So for this, you should be aware about how the electromagnetic wave diagram looks like. For that, I'll just go at the extreme bottom where I have attached the photograph for the same, the electromagnetic spectrum. And if you notice, this is the band for frequency. 10 power of 16 is over here, and that is with respect to, if you see, ultraviolet band. So the principal is ultraviolet. Now to the left of this, that is the lower frequency, comes out to be visible, infrared, microwave, and radio. Let's go ahead and see that out of all of these options, which one is given to us in the question 25. So first of all, principal region is either ultraviolet, only ultraviolet, so either C and D is the possibility. And visible light was to the left of the ultraviolet, so C becomes our answer for question 25, because the for the visible light we were having lower frequency as compared to ultraviolet. And if I check about X-rays, X-rays must be towards the right side, having the higher frequency. So yes, as we see over here, X-rays to the right of ultraviolet, which is having higher value of the frequencies. That is how we solve this particular question. Now let's talk about question 26. It is given that a source of sound emits waves of a constant frequency. So there is a source of sound which is continuously emitting waves that is having same frequency. Now that source is moving at a constant speed in a straight line relative to a stationary observer. So the scenario over here is something like this. You are having, let's say, a road. On a road, there is a stationary observer somewhere over here. Let's say. Now there is a source of sound which is going to pass by this observer. Okay, so there is, let's say, this is a source of sound which is going to pass by the observer. You can assume that the source of sound is nothing but, let's say, a sports car or a sports bike which is having a loud engine, right? So how the sound is going to, like, feel to you if you are just standing observing stationary on the road? It's going to be like, something like this. Zoom. So yeah, I know I'm sounding a bit funny over here, but yeah, that is what I'm trying to explain. That whenever the source is going to come towards you, the frequency is going to be higher of that particular sound. Now, the moment it starts going away from you, the frequency that you're going to observe is going to be fading away slowly with time. So based on this, the question is stating which velocity of the source, so the source that is moving, which velocity of the source gives the smallest observed frequency. So we need to find out the smallest observed frequency based on the given option. So clearly it makes sense that away from the observer is going to give you the smallest value of frequency, because towards is going to give you the kind of, like, zoom, so very high frequency. And the moment it goes away and away from you, it's going to be like zoom. So the frequency is going to be much less. And therefore, it's going to be either option A or option B for sure. Now to get the smallest value, we need to figure out which speed of the source is going to give that smallest observed frequency. So for that, we can use the Doppler's effect formula, which is given by the observed frequency is equal to the Fs, that is the constant frequency emitted by the source, times the velocity of the medium in which it is traveling, which is sound in this case. So it's the velocity of the sound uh, with respect to the air. And what was I saying? It's going to be that same value of V plus or minus the value of the velocity of the source. So in the question, they're asking which velocity of the source, so which value of this Vs is going to give you the least frequency. And we use plus when the direction is away from the observer. We use minus when it's towards the observer. So obviously it makes sense we are going to use plus. So let's ignore minus. So to decrease the value of f naught, I need to increase the value of denominator. So out of the two, 10 is giving me the much higher value as compared to 5. So if I use Vs is equal to 10 as compared to 5, the value of f naught is going to be less for 10. And therefore, B is going to be our answer for question 26. Moving on to the next question. What could describe the time base of a CRO? So if you have noticed in previous year questions, you have this CRO with this kind of divisions, and we see that it's usually given that in 1 centimeter, what is the value of the time in that particular division? And therefore, based on that, it's not the frequency or the number of divisions on the screen per unit frequency. The unit of division on the screen per unit time, no, it's not like that. It's not per unit time, but it's the time per division. So D becomes our final answer. It's the time per division on the screen. So on the screen, this divisions is going to tell you about the information about the time. Based on that, then we can calculate all the other stuff. So D becomes the final answer for question 27. Now for question 28, what happens when two waves superpose? So that's the principle of superposition. The displacements are simply going to be added together, and therefore B becomes our straight away answer without even thinking about it. Now for question number 29, an electromagnetic wave is diffracted. An electromagnetic wave is diffracted as it passes through a single slit. So we are having a slit like this, and the width of the slit is larger than the wavelength. Which change will decrease the amount of diffraction of the wave? So we want to decrease the amount of diffraction. So let's say that waves were coming like this. I'll use another color. So let's say that the waves were coming with this, and then after the slit, it started giving you the diffraction. And we know that the slit, the wide, the value of the slit or the width of the slit must be small or equal to give diffraction uh, of if it's equal to the value of lambda, width of the slit must be small or equal to uh, lambda value to give diffraction with greater than equal to lambda value. So in this case, the question is asking us what change is going to decrease the amount of diffraction. So to decrease the amount of diffraction, we need to decrease the value of lambda. So let's see out of all these options, how we can decrease the value of lambda. So if we decrease the value of frequency, obviously we are going to increase the wavelength because we know that V is equals to F lambda. F and lambda are inversely proportional. If I decrease the F, lambda will increase. So we don't want to increase the lambda, we want to decrease the lambda. So A is not the option. Then decrease the time period of the frequency. Sorry, decrease the time period of the wave. Now we know that time period is inversely proportional to frequency because F is equals to 1 by T. So if we decrease the time period, F is going to increase. And the moment F increases, your lambda will decrease. So B could be our answer. Let's check about option C and D. If we decrease the width of the slit, as I told you, if the width is going to be decreased, it's going to be more than lambda. So the diffraction pattern is going to increase. It's not going to decrease. So even C is not possible. Now, if we increase the wavelength in the first place, it's not going to decrease the amount of diffraction as compared to what we have observed earlier. Now, if we eliminate all the options, the only option that is left is B. And therefore, B will be the final answer for question 29. Now, moving on towards the next question. The diagram shows visible light incident normally on a diffraction grating. Again, a very typical question that you may expect in the waves chapter in the MCQs. So, we are having the incident light. We are observing the fourth order maxima over here. So, n is equal to 4. The value of theta is given to us as 53. And we can basically use d sine theta is equals to n lambda over here right away without reading the question. I can say that. Okay, let's go ahead and read the question. A pattern of intensity maxima forms on the screen. We know that it's going to be like this: 1, then 2, 3, and then 4 will be somewhere over here. And the same pattern, exactly the same pattern you can get over here in the bottom part as well. So uh, the line connecting the center of the fourth order intensity maximum of the center of the diffraction grating forms an angle of 53 degrees with respect to the center line. The grating has a line spacing. So in the grating, you can have a lot of lines. So distance between these lines is given to us as 2.7 to 10 power of 6 meters, which is given as D in this formula. We simply have to find out the value of lambda. We are given the value of D, we are given the value of theta, we are given the value of N. So lambda will be equal to my D, which is 2.7 into 10 power of minus 6, times sine theta, which is sine 53, divided by N, which is 4. And if I do this in my calci, so 2.7 to 10 power of minus 6 sine 53 divided by 4, it comes out to be 5.4 10 power of minus 7. So B is going to be our answer for question 30. This kind of questions are very, very typical if you are someone who is studying waves, and if you're not aware about this kind of experiment, then you're going to lose a lot of marks. Okay, so just make sure this concept is pretty strong. Now let's focus on question 31. A horizontal glass tube closed at one end has a layer of dust laid inside it on its lower side. Sound is emitted from a loudspeaker that is placed at the open end of the tube. The frequency of the sound is varied. So the frequency of the sound produced by the loudspeaker is going to be varied. And then at a particular frequency, a stationary wave is formed inside the tube so that this kind of heaps are formed inside the dust. Now the distance between the four heaps of the dust that is shown over here is 30 meters, 30 centimeters. The speed of sound in the air is within the tube is 330 meter per second. Now what is the frequency of the sound emitted by the loudspeaker? So V is equals to F lambda. So we need to find F. V is given to us. So with the help of this concept of the distance between the antinodes that are being formed, we can first of all find out the value of lambda, and then with the help of that lambda, it will be helping us to find out the value of F. So we know that distance between every antinodes is given by lambda by 2. So this is my lambda by 2, this is also lambda by 2, and this is also lambda by 2. So we are having 3 lambda by 2, which is equal to 30 centimeters or 0.3 meters. So based on this, I am able to say that my lambda will be equal to 2 into 0.3 by 3 is going to be 0.2 meters. So now I'm having my lambda. I'm also having my value of V being 330. If I substitute my V and lambda, I'll be getting my F as 330 by 0.2. And if I do this in my calc, 330 by 0.2, it gives me 1650 hertz. So that is going to be our answer for question number 31. Just make sure you are aware about this concept of how different nodes and antinodes are being formed, and based on that, what are the distances between the two antinodes or two nodes, or between the nodes and an antinode. If you are aware about this concept in terms of lambda, then solving this type of questions becomes a piece of cake. Now going to question 32. There is a current in a resistor for a short time interval. So there is a resistor in which there is a current for some short time interval. Which statement about the total charge that passes through the resistor is correct? So there will be, as current is flowing, there is this charge, right? We know that Q is equal to IT, and your I is nothing but the flow of the charge. So this current, which is present in the resistor for a shorter period of time, it's nothing but the rate of flow of the charges. And these charges are going to be in the format of elementary charge. So if there is this charge passing by, it's going to have a value of 1.6 10 power of minus 19. Like this, I am having a lot of different charges. So yeah, it's going to be equal to N times E, right? So based on this, let's go ahead and look into the options and see which value is going to be correct for the total charge. It can take any value. It can take any value if it's in the format of, like, multiple of an elementary charge, because charge is quantized. So let's see if this is correct or not. Let's read option B. It is an integer multiple of the elementary charge. So this is what is meant by the charge is quantized. So for sure B is going to be our answer. It's going to be an integer multiple. So if there is one charge, value will be E, that is 1.6 10 power of minus 19. If it's two electrons, so it's going to be 2 times e to the power of minus, that is 2 times 1.6 into 10 power of minus 19. So it's an integer multiple of the elementary charge. So B must be correct. Now for question 33, the potential difference V across the filament length is slowly raised from 0 to its normal operating value. Which graph shows the variation? So this is typical question for the filament length. And if you open the textbook, you will be finding this graph over there. For question 34, an electric current of 12 ampere in a wire of length 0.35. An electric current of this is it present in the wire of this length. The average drift speed of the free electrons in the wire is this. This is your current, this is your length. How many free electrons are in the wire? So basically we can use the concept of drift velocity, that is I is equals to N A V E, and I know that my N is the number, then the amount of electrons per unit volume. So N will be the number of electrons, the free electrons in a unit volume, and unit volume can be represented as area into length of the wire. And therefore, if I have to rewrite this, I is equal to, so N by AL into AVE, where A is going to be the area, so area is going to be cut out. V is the drift velocity, A is the elementary charge, I is the current. So based on this, if I find out the value of N, the free electrons value, it's going to be N is equals to IL by VE. So I is given to us as 0. Not 0 point, but 12. Then L is 0.35. Then drift velocity is 5 into 10 power of minus 4. And then the elementary charge is 1.6 10 power of minus 19. And if I'm using my calci to get the answer over here, 12 into 0.35 divided by 5 into 1.6 into 10 power of minus 4 minus 19 comes out to be 5.25 10 power of 22, which means that our only option that suits this is option B. So B is the correct answer for question 34. Now, three resistors are connected to a cell of a negligible internal resistance. Which circuit has a combined resistance of 100? So if you're aware about the concept of how to add the resistors in the circuit, then doing these questions is not going to be hard. So let's talk about your option A. So there is 100 over here, and if I calculate the resistance, the net resistance of this parallel combination, that is going to be 1 by 100 plus 1 by 50, and the reciprocal of this. So obviously this is not going to be the answer because it's going to be more than 100 if I add 100 on top of this value. But still, if I have to show you the value for this, it comes out to be 33.333. So 33.333 plus 100 is obviously more than 100. So A is not the option. Let's go to B. Now, when the value in the parallel are always equal, both the resistors, the resultant is always the value half of this value. So basically, if you do 1 by 100 plus 1 by 100 and do the reciprocal of this, it's going to be 50. You can check it right away. Okay, using your calci, you can do this. So this is 50, this is 50, that makes 100. So we can say that the answer for 35 is option B. I don't even need to try C and D. You can go ahead and check this just in case if you are willing to do so. But yeah, the answer for question 35 is B because yeah, that's how it's going to give us the total combined resistance of this circuit as 100 ohms. For question 36, it is given that each of Kirchhoff's law or the Kirchhoff's law is a statement based on the conservation of the physical quantity. Which quantity is conserved in each law? So the first law is for the current, the second one is for the EMF, and therefore for the current it's going to be the charge, and for this it's going to be the energy. So it's a theoretical question, and the answer is going to be A for question 36. And for question 37, a cell with an EMF 1.5 delivers a current of 0.26 amperes in the circuit to a resistor of 5 ohm connected between its terminal. So basically the situation is like this. You are having 5 ohms, then you are having the cell, And you're also going to have internal resistance over here in the cell, and the current flowing is basically 0.26 amperes. Now you have to find out the value of this internal resistance. So basically E is equals to I of R plus R is what I'm going to implement, the formula that we have learned in the electricity chapter of AS level physics. So 1.5 is equal to 0.26 times 5 plus R. And then if I do this calculation, 1.5 divided by 0.26, and then answer minus 5, it comes out to be 0.769. So it is 0.77. Answer is going to be D over here. So if you're aware about the concept of how the current flows inside the circuit, and based on that how we can create this kind of equation, if you're aware about the Kirchhoff's second law, then forming this equation is very easy. Now coming to the 38th question, which is not a quark flavor. So charm is a quark, strange is a quark, up is a quark, meson is not a quark. So B is going to be our answer. Basically, in the radioactivity, the questions are always theoretical, so this kind of things are not going to be that difficult if the theoretical part is clear. How many down quarks are in a nucleus of hydrogen? So in this nucleus of a hydrogen, there is one proton, and the proton is composed of UUD. And there are two neutrons because the mass or the atomic number is 3, and therefore it's going to be 2 plus 1 3. So and neutrons is going to have DDU. So there are two such neutrons, so DDU, and one proton UUD. So 1 2 3 4 5. There are 5 down quarks in this particular hydrogen. So answer is going to be D. How many down quarks in this nucleus of hydrogen? So there are two neutrons, one proton, to make this 3 over here. One is the proton number. So yeah, proton has UUD structure, neutron has DDU structure or UDD structure. Based on this, we can see that there are 5 down quarks. And for the question 40, an isotope of a boron decays beta plus emission. So it is giving out anti-electron as an output. Which particle is emitted on top of beta plus particle? So whenever there is something anti that is released, there will be always a part of matter. So whenever there is an antimatter, there will be a matter. So out of all the option, if we check, um, antineutrino, it cannot be, because see, beta plus is already anti, because beta minus is electron, beta plus is anti-electron. So this is not true. So with anti-electron, it will be its electron, and therefore, because electron is the matter particle with respect to this anti-particle beta plus, so answer will be B in this case. Alright guys, so that's it about this video over here. I hope that you were able to understand all the solutions or the steps in the solutions. Just in case, if you're having any kind of doubts, don't think if it's silly or not. If you think there is a doubt, always make sure to comment it below this video and I'll reach out to you as soon as possible. And don't forget, if in case of any kind of enquiries for the online classes for AS and A level physics and mathematics, you can contact me personally on my WhatsApp via this number. Stay tuned as I will be uploading more and more videos from the October-November 2024 series for AS and A level physics and mathematics for different papers.